Hello everyone, my name is Josh and welcome to this channel. This is my first video on this channel, and this channel is mostly going to be focused around helping with some maths. Now, I'm happy to cover any level of maths from like primary school level or elementary school, if American, to A-level maths, which is age 18 maths. I'm a student of physics at the University of Manchester in Britain. And so I'll just be talking through whatever topics people want help with. So today, because this is the first video, I'm just going to talk about simple ways to solve equations. So I'll talk about factorizing, I'll talk about using the quadratic formula, and I will talk about completing the square. So I put in timestamps for when these are in the video. If you have any topics that you want me to cover for this channel, whether it be go through a worksheet for your maths or try and help you learn a topic, just comment it or contact me somehow, and I'll take a look and see if I can make a video on it when I get time. Okay, so the first method I'm going to talk to you about is factorizing equations. Now, factorizing is a very useful method, which comes up a lot. I still use it, even though I'm 20 and still just doing maths at this age. So, say for example, we've got a quadratic equation, and we've got a quadratic equation of x squared plus 3x minus 4. And we want to get a value of x out of this equation. So if we're told that we need to factorize this, that means we need to split it up into two brackets. So in order to do that, what we would do is we would look at the factors of our terms in x. So in terms of x, we have 3. Now, we have to pick two numbers that add together to make 3 and that multiply together to make minus 4. So there's loads of different numbers we can use. We could try using 1 and 2, they add to make 3. We could try using 4 minus 1. We'll just write these ones down for now. So 1 and 2, yeah, they add to make 3, which is good. But 1 and 2 multiplied make 2, and that's not equal to minus 4, so we can't use those ones. So we'll cross them out. So 4 and minus 1, they add together to make 3. 4 plus minus 1 is 3. And 4 times minus 1 gives minus 4. So these factors are okay for us. So what we want to do now is split those up, that term of 3x, up into x squared plus 4x minus 1x minus 4. So we now have that. Oh, I should mention also that these equations need to be equal to 0 for us to solve them. So, for this now, we've got this x squared plus 4x minus 1x minus 4. So, we're going to draw an imaginary line down the middle of our equation. So, we've got x squared plus 4x. So, out of that, our common factor is x. So, we can take a factor of x out of it. If we take a factor of x out of x squared leaves x, and x out of 4x leaves plus 4. So that gives us that factor. Now we want this same factor in the brackets on the right hand side as well, out of these, in order to solve this. So on this side, so we've got minus 1x minus 4. So our common factor is minus 1, because that's all that these two terms have in common. So we take out our minus 1. And that leaves us with an x in the inside if we take a minus 1 out, and it leaves us with a plus 4. And that's all equal to 0. Now, we've got an x plus 4 on both sides, so we can take a factor of that out. So if we take a factor of x plus 4 out, leave that in brackets there, that leaves us with an x minus 1. So we put an x minus 1 in there, and that's equal to 0. So we've now successfully factorized it. If you're on the question to factorize, that's as far as you need to go. But if it wants you to solve the x, we can do that very simply with one more line. So in order to make this equation equal to 0, like it's told us, one of these brackets has to be equal to 0. So that gives us solutions when x is equal to the negative of whatever it's in the bracket with. So in this case, if we do x is equal to -4, that would mean -4 plus 4 is 0. So the whole equation is 0, because that's 0 times x minus 1 equals 0. Likewise, we can do x equals 1, and that would be 1 minus 1 is 0 times x plus 4, it's all equal to 0. So that means our two solutions to this equation are x equals -4, and x equals 1. So that's how you would solve through factorizing. There are special equations which you can watch out for when factorizing, and these are called difference of two squares. So a difference of two squares is when you get an equation in this format with no x coefficient. So it's just in terms of x squared and a constant. Now, this constant, if this is a square number, so for example, 4, 9, 16, 25, then that means you can solve these special ones, which will have an interesting value. So in order to solve this equation, you look for, again, factors. So this time it's -4 that can, so you want two numbers that can multiply together to give -4. And those two numbers also need to be equal to each other. So in this case, we use 2 and -2, because those two add together to give 0, because we have a 0x coefficient, and they multiply together to give -4, 2 times -2. So that means that we can solve this if we have x squared plus 2x, let me rewrite that x in, -2x minus 4 equal to 0. So we now solve this exactly the same way again. So x, take a factor of x out, that leaves x plus 2 in the brackets. And then here we take out a factor of -2, because that's what these two factors have in common. Inside, taking the -2 out, we get x, and taking the -2 out of that, we get plus 2 equals to 0. So we have, again, brackets here, so we get x plus 2 on this side, and what's left is x minus 2. And that means that when we want to solve for x, this time we have x equals -2, because -2 in this bracket will give us 0, and x equals +2. That will give us 0 in this bracket. So you'll notice that the two solutions in this special case of difference of two squares, your two values of x are just the negative of each other. So if you spot one in this format, where this constant is a square number, then you know that you can straight away factorize it to whatever the square root is of this number. So in this case, square root of 4 is equal to plus or minus 2. And so you know that your two values of x are going to be x plus 2, x equals +2, or x equals -2. And that's just a method that can save you time, say, in an exam situation, or if you just want to get to your solutions quicker. And you can always check your factorization of equations just by expanding them back out again. So say, for example, if we wanted to check that our value here was right, we'd expand. So we'd go x times x, that's x squared, x times -1, that's minus x, 4 times x, that's plus 4x, and 4 times -1, that's -4, equals to 0. So then we group up our like terms, so we get x squared plus 3x minus 4 is equal to 0. And that is exactly the same as the equation that we started out with. And so we know that our answer is correct. If it comes out to something that isn't the same as what you started with, then it means that we've made a mistake somewhere and we need to try again. Okay, so that comes up the factorization method of solving equations. Okay, so what we'll do now is go to a new page and start through a method called the quadratic formula. Now this is a really long word to write, and my handwriting is very messy, so I'm writing in block capitals. Quadratic formula. So the quadratic formula is another way to solve equations if you can't factorize them. This can make it quite helpful if you're stuck with one that can't be factorized. So often you will need a calculator for this because sometimes you'll get some strange square roots in it and it will be too difficult to solve by hand, but other times you won't. So the quadratic formula is this: minus b plus or minus the square root of b squared minus 4ac all over 2a. Now this is the solution to give you x, and this works for a general quadratic of ax squared plus bx plus c equals to 0. So in this, a, b, and c are just your coefficients of each term. So if we take our example from before, which was x squared plus 3x minus 4 is equal to 0. In order to match up our coefficients, we take a is 1, because there's only 1x squared, plus b is 3, because there's 3x, and c is equal to minus 4. So in order to solve our value for x, we just substitute all of this into the equation. So that is minus 3 plus or minus the square root of 9 minus 4 times 1 times minus 4, substituting in our values, all over 2 times 1, so 2. And that's equal to x. So we can simplify this down. This bracket here is 4 times minus 4, which is minus 16, but we're subtracting it, so it's 9 minus minus 16, which is 9 plus 16, which is 25. So we go minus 3 plus or minus the square root of 25 all over 2 equal to x. So we can now solve this equation. So we'll start by taking the positive of this. Because when you have a plus or minus in an equation like this, it means you can solve it for minus 3 plus root 25 over 2, and you can solve it for minus 3 minus root 25 over 2. So we'll take this as minus 3 plus root 25 over 2 equals x to start with. Now the root 25 is just equal to 5. So that's minus 3 plus 5 over 2 equals x. So that is 2 over 2, so x is equal to 1. And that's one of the solutions we got previously when we tried factorizing it. So for the other solution, we take minus 3 minus root 25 over 2 equals x. So that's minus 3 minus 5 over 2, so that's minus 8 over 2 equals to x, and that means that x is equal to minus 4. Now that's given us two solutions of x equals minus 4 and x equals positive 1. Now if we compare to our factorization method earlier, we find that it's given us exactly the same values, and that's good. That means it's worked, because whichever method you use, it should always come out with the same solutions of x. This one is not so easy to test if you've done it right, as factorizing is, which is why factorizing is my personally preferred method. But sometimes you'll be told to use this formula, and so it's important that you know it and can use it comfortably if you see an equation to use it with. So in the case like before where you've got x squared minus 4, equal to 0. Now, in this case, you do exactly the same thing, but your b is equal to 0. So, in this case, you get plus or minus the square root of 0 minus 4 times minus 4. So that's all over 2 is equal to 0. So this gets you plus or minus square root of 16, because your minuses cancel out. So it's 4 times minus 4 minus 16. Then minus of that is plus 16 over 2 is equal... Sorry, these should be equal to x, not equal to 0. So that's equal to x, and that's equal to x. So that, when solved, gives you plus or minus 4 over 2, which equals plus or minus 2. And that's equal to x, which is exactly the same as we worked out before. X is just plus or minus 2, which is good. Again, it's just another method to use to solve these, but you'd want to factorize it if you saw a difference of 2 squares like that. Okay, so I'll move on to the third and final method I'm going to talk about today, and that is completing the square. Now, ooh, my pen is freaking out. Complete the square. Now, I remember back when I was in school, I hated this method. I didn't understand it at all. And I don't know why I didn't understand it at all, because it's not too bad once you understand what's going on. So to do this, I'm going to use a different equation to solve, because it's easier if you have an even coefficient of x in it. So the equation that I'm going to use is x squared plus 6x minus 7. No, plus 7. Tell a lie. Equals to 0. So, completing the square is a little bit of a strange method. So what you do, you say x plus half of the coefficient of your x term. So based on the previous terminology we had, it'd be x plus b over 2 squared. So here we go. 6 over 2 is 3. So we go x plus 3 squared as the first part of it. Now, if we expanded this out, we'd get x squared plus 6x plus 9. Now, we're not supposed to have that plus 9 in it, because we see in the equation we've got plus 7 here. So what we want to do to make things simple to start with is whatever this number squared is, we want to subtract that off. So we'll take away that 9 for now. And then we also need to add our 7, because we've not touched this 7. All we've done is taken this and put it in a bracket, and then subtracted what extra it gave us. And we say that's equal to 0. Now we can simplify this down, so we get x plus 3 squared minus 2 is equal to 0. So that is all you need to do to complete the square. And then you rearrange this for x if you want to solve it. So yeah, using the method from before, it's just, it looks horrible written down in general. But that is what it is. It's rather ugly compared to some of the other methods that we've used. But this is just how you do it. If you're told to do it in like an exam situation, for example. So yeah, all we've done is taken half of this coefficient, do x plus that squared, subtracted what that is squared, and then added the remainder that we had from our equation onto it. So now in order to solve this, we just need to rearrange for x. So we go x plus 3 squared equals 2. We just added 2 to both sides. X plus 3 equals square root 2. Now, depending on what level of maths you're doing this at, you will need plus or minus here, because you can take positive square root 2 or negative square root 2, which is just not nice. So now to finally solve for x, we get x equals plus or minus square root 2 minus 3. Now that solution does not look satisfying at all, but the point of using this method is, again, we haven't been able to factorize it, and it's going to come out as some horrible decimal, which, you know, sometimes that's just the answer. I don't like it when that's the answer, but that's all we can really do. So if you were doing a calculator paper, you could either give it like that, or you could work out what each one is. So you'd have root 2 minus 3, and x equals minus root 2 minus 3 as your two solutions. I can't show you the factorization method to prove that this is right, because you can't factorize this equation. That's the point of using complete the square. You can check to see if you've done it right by taking this line that you've put in and expanding it back out again. So if we expand what's written here, we should come back out to what we had initially. So if we take x plus 3 squared minus 2 equals 0, and we expand this out, so we go, that's the same as x plus 3 minus 2 equals 0. That gets us, expanding this out, x squared plus 3x plus 3x plus 9 minus 2 equals 0. We collect up our terms, so x squared plus 6x plus 7 is equal to 0. And that's got us back to where we were at the start. So we know that our attempt at completing the square has worked. We've come out with the same as what we'd completed the square to. So these are the three simple ways that you can solve a quadratic equation for x, so quadratic just being up to order x squared plus something x plus a constant. They're not too difficult with a bit of practice. If you've struggled to follow me through this, I will also upload these files to a Google Drive, which you'll find a link to in the description of this video. I hope that this little video has helped you to understand how to solve using these three different methods. And just comment down below if you have any further questions or want my help for any particular question that you can't do by yourself using these methods. If there's any topics that you want me to cover in a video, or any worksheets you want me to go through the answers to, then again, just comment down below or get into contact with me somehow. And as soon as I can, I will make a video on them if possible. Thank you for watching this video. I hope it's helped you learn something. If you want to ask me any questions, just let me know. But thanks again for watching, and good luck.